Okay, so where we left off at the end of class was we were talking about how to find the class representative for each set of grouped data. We talked about we would use the class midpoint. Our class midpoint is going to be two consecutive lower class limits. It's the average of the two. So our class midpoint will be our representative. Okay, and remember it's the average of, we'll say this is lower class limit 1 and lower class limit 2, and it's the average of the two. So it's two consecutive lower class limits. So we'll say lower class limit n plus lower class limit n plus 1, all divided by 2. We can find these individually by calculating them all. Now, if you're asked for the lower class limit, that's what you want to do. What I'm going to show you is a shortcut way of doing that on your calculator. So remember, our class representatives in group data are the average of the two. So, and that goes in list 1 because that's the actual representative. So when we look at this, we're going to have 1, 15,000, 2, 17,000, 4, 20,000, and so on. But I don't want to have to calculate each one of these, write them down, and then plug them back in. So I'm going to do this here. Notice I'm putting this in parentheses. So this is 15,000. So I'm telling the calculator, add 15,000 and 17,500, and then divide that by 2. And that gives me my first class representative of 16,250. Then I'm going to do the same thing. Add 17,500 and 20,000, and then divide by 2. Then we're going to take 20,000, add it to the next lower class limit of 22,500. And notice the class width is 2,500. So that's going to play an important part whenever we find our last class representative. So we have 22,500 and 25,000. We divide that by 2 and get 23,750. Okay, now that we're at our last class, the lower class limit is 32,500. So one of two things can happen. I can recognize that the next class would technically start at 35,000 and I can find the average. Okay, so I could do 32,500 plus 35,000 and then divide that by 2. So find the average of those two consecutive lower class limits. Now, clearly I typed something in wrong, added an extra 0. But if that happens, you can just delete that entry out and then start over. The other thing that I can recognize is that my class width is 2,500. And of course, that's going to be the distance between the class midpoints as well. So I can also just take the 31,250 plus 2,500, and that's going to be my next and final class midpoint. Once we have all the class midpoints entered, we want to enter the frequency. So we have 1 in the first class, 2 in the second class, 4 in the third. 27 of our Priuses sold for approximately 23,750. 38 of them sold for approximately 26,250. 15 of them sold for about 28,000. None of them sold for 31,000, and 2 of them sold for 33,000. Once we have this data entered, now we can go and calculate the approximate average or approximate mean for the advertised prices of the cars. So we go to stat. We want to calculate summary statistics. So mean, median, mode, all your measures of center, all your measures of spread are going to be under the summary statistics umbrella. And so once I go and I calculate one variable statistics, now I do actually have the right things in here. My data is in list 1. But remember, this is group data. This is not data that's all in one big list. That's all just listed out for you. So you have to tell the calculator, hey, my data is group data. So it has a frequency list. So remember, you're looking at this frequency list here. That's important with group data. If you forget that, you're going to get your answer wrong. You calculate that value. That gives me an average. Now, normally I tell you to round to 1 decimal place, but we're talking about money. So I'm going to round to 2 decimal places. So I have $25,575.84 is the approximate average price of those cars. So $25,575.84. And that is your approximate average. Now, I can also find the approximate median. That's going to be a bonus on the test. So you need to kind of be looking into that if you're interested in the bonus. But you should be able to find the mode, an approximate mode. You should also be able to find a standard deviation, which of course is from the calculator itself right here. This is a sample, so it's $2,711.61. And then that helps us determine what a quote unquote average price of a car would be. And we're going to go ahead and do that as well. So you can kind of look at that and refresh that for the empirical rule. So the standard deviation, and remember it is a sample standard deviation, is about $2,711.61. So in order to find the range that we're looking for, we're going to multiply this by 2 and get $5,423.22. To get an average range, to know whether or not a value is far away from average, we're going to add and subtract. So the low end of prices is going to be $20,152.62. So that's the low end of quote unquote average or expected. And then the high end is going to be $30,999.06. So what that tells me is that any cars that sold in this range right here and in this range right here, so kind of more in the middle, there were none in here, so we can exclude this. So these two cars were also outside of the expected value. So either they'd been in an accident, they had super high mileage, they'd had some other issues, there was some sort of damage to the car, could be a possibility of why they sold here. And then here, this could be have particular features that maybe somebody would want, and that's why those sold so high. So when we see those things, that's what these values tell us. They tell us to question why they were so low or why they were so high. So that's what you're looking at with those. Now, weighted means, this is an official formula here for weighted means, so you can kind of look at that and keep that in mind. And when we calculate weighted means, it says Bob goes to the By the Way nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate covered peanuts, and 1.5 pounds of cashews. So he has 1 pound of raisins that cost $1.25 a pound. He has 2 pounds of chocolate covered peanuts that are $3.25 a pound. The last thing he buys are 1.5 pounds of cashews at $5.40 a pound. It says, what is the cost per pound? So that tells me kind of how I need to divide, because a lot of times that kind of gets confusing. It's like, okay, what do I divide? What am I dividing by? That kind of thing. So we want to know the cost. So we have to figure out a total cost and then per pound. So I need total pounds. So this tells me I'm doing total cost divided by total pounds. So the first thing I'm going to do is figure out total cost. So I'm going to multiply. So the raisins I spent $1.25 on. The chocolate covered peanuts I spent $6.50 on. And then for the cashews I spent $8.10. Now I need to figure out the total cost. So I just add all those things together. So I have $1.25 plus $6.50 plus $8.10. So he spent $15.85 on all of the products he needed to make his mix. Now I have to figure out the total pounds. So we're going to divide the total cost, which is $15.85, by total pounds, which is 4.5 pounds. And that's going to give me the cost per pound, which is approximately $3.27 per pound. Of course, it's 3.268, and I round that to the nearest cent because that's typically how we express money, and that is our average price per pound. All right, so we just found the approximate standard deviation from group data, so we don't have to do this. We talked about what would be considered the average price of cars, and remember 2 standard deviations is what is typical and what we would expect. 95% of all cars should sell between those 2 values, and then anything outside of that range would be considered unusual. So anything outside of 95% would be considered unusual.